network and we have to find the value of current in various arms using Kirchhoff laws. We know when we have to use Kirchhoff laws, first is we look out of the junctions. What are the junctions? How many junctions they are there? And at the junctions, first we start with the KCL, that is Kirchhoff current law. After that, we give the names to the closed loops. We look out for the loops and then we apply KVL, that is Kirchhoff voltage law, mesh rule or loop rule. From there we get some equations. Then we use the equations of Kirchhoff current law and Kirchhoff voltage law to find what has been asked. So over here we see that is in this network we have a junction. Junction is where more than two wires they are getting connected. So this is junction 1, 2, 3 wires they are meeting over here. This is junction 1, 2, 3 wires they are meeting. So this is also junction 1, 2, 3. This is also junction. This is not a junction. This is simple wire only. So we have 1, 2, 3 and 4 junction. Once we identified junctions, then we start with the KCL, that is Kirchhoff current law, node rule or junction rule. Let's say over here we start with this A junction. So from here I1 current is coming over here, I2 we have taken in this direction. So remaining is we have taken I1 minus I2 in this direction. If we had taken I3 in this direction, so I3 plus I1 should be equal to I2, but over here we have directly taken I1 coming over here. So I2 goes over here, the remaining I1 minus I2 goes over here. So in this one arm, whether there is a resistance or whether there is a battery, in one arm there is going to be only one value of current and the direction of current is also going to be one direction only. It is not that some current is coming this way and some current is coming this way. This is not possible. In one wire, in one arm, the current is going to flow only in one direction. And when we say that is direction of current is like this, so we are talking about the direction of conventional current, positive current. So I1 minus I2 is here. So now when the I2 comes over here, we have said that is I2 is this way and this way we have taken I3. So this way the current will be I2 plus I3, that is summation of these two. That is once again we are applying Kirchhoff current law. I2 plus I3 comes this way. I1 has gone this way from here. I1 has gone this way. So the remaining current which we can say is I2 plus I3 minus I1. This current direction is this direction. Over here also current is going in this direction. Both these currents they are approaching the junction. So obviously the current in this wire should be in this direction. So this current should be equal to this plus this. So if we add I2 plus I3 minus I1 plus I1 minus I2. So this gives once again I3 only and we say I3 and I3. So once we are done with KCL, then we go for the KVL. We have given A, B, C, D, E. So that now we can identify all the loops and look out for the loops, that is how many loops they are there. We see that this is a loop, that is A, B, C, A is a loop, A, C, D, A is a loop. Even bigger loop is there, A, B, C, D, A, this is a bigger loop. This is also a loop. So there are many loops. We need the same number of equations as we have the number of unknowns. Like over here, we have I1, I2 and I3. We have three unknowns. So we need to have at least three equations to find the value of I1, I2 and I3. So for that we can consider any loops. We can consider this one loop, this second loop and this third loop. And from there we can get the values of I1, I2 and I3. And if we choose loops like one is this bigger loop, the second is this loop, the third is this loop. From there also we can get the same values of I1, I2 and I3. Once we get the equations, we can solve them and we get the desired values. So let's take ADCA. ADCA. We also know that is in the direction of current, in the direction of conventional current, when we are moving in the direction of conventional current, there is a loss of potential and against the current, we are gaining potential. Similarly, in battery, when we are moving from negative potential to positive potential, there is gain of potential. But if we are moving from positive potential to negative potential, there is loss of potential. Loss of potential is negative, gain of potential is positive. In the direction of current, when we are going across a resistor, then once again there is a loss of potential, this will be negative. And when we are moving against the direction of current, that is we are moving from the lower electric potential to higher electric potential, so there is a gain of potential, once again it is going to be positive. So we have taken the various loops. So when we take ADCA, that is ADCA, we are going in this loop. Let's move from here to here to here to here. We are starting with the A, we have to close the loop at A only. They have to be closed loops. When we say Kirchhoff voltage law, it is nothing but conservation of energy principle only. As we say, let's say if we have a building and one point can only be at one height, it cannot be at a height of let's say 50 meter also and 60 meter also. one point can only be at one height. Similarly, the electric potential of one point can be a one single value only. It means the potential difference between the point and the point itself is going to be equal to 0. That is what is KVL. When we say, let's say from here to here, suppose if we take this loop, we take some potential difference across this, we take across this, we take across this. So finally the net potential difference between this point and this point, that should be equal to 0. It means across some resistors and some batteries, there may be some gain of potential, but across some other there is going to be loss of potential, so that overall the potential difference for this point A, that has to be equal to 0 for any closed loop. That is what is Kirchhoff voltage law. If we take A, D, C, A, so it is, we are going in this direction, so this is negative. We are using I into R only, 4 into I1 minus I2, because this is a loss, this comes out to minus. Now when we are going from D to C, that is, we are going from, because the conventional current is flowing in this direction from higher electric potential to lower electric potential, and when we are going from here to here, we are moving from a lower electric potential to higher electric potential. So that's why there is going to be gain, that is plus 2 I2 plus I3 minus I1. So when we come over here, we are moving in this direction from higher electric potential to lower electric potential. So this is minus I1, and then negative to positive, this is plus 10 is equal to 0. When we go for A, B, C, A, so this is our journey. When we go in this direction, so this is minus 4 I2. In this direction of the current, it is minus 2 I2 plus I3. Over here, once again, minus 1 I1 plus 10 is equal to 0. When we take this loop, B, C, D, E, B, so it is going to be, from here to here we go, so it is once again the direction of current, so it is going to be negative I into R. When you go from here, once again the direction of current, minus 2 I2 this thing, minus 2 I2 plus I3 minus I1, so once again it is negative. When you go from here to here, that is from negative to positive we are moving, so there is a gain of potential, plus 5 is equal to 0. And now we can solve these equations. We can get the value of current in various network arms like this.